Okay, we're recording, and last time we were looking at the rearrangement inequality, and I made the observation that the rearrangement inequality was along the right lines. What I'm going to do is remind you about Chebyshev's inequality. I hesitate to say it's more powerful than the rearrangement inequality, but it's more powerful in a certain sense. Anyway, let me just state it. We've got numbers a1 less than or equal to a2, blah, 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 an, and b1, da, 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 bn. Then a1, b1 plus all the way through to an, bn over n. So the weighted average of the product, is greater than or equal to a1 plus all the way through to an over n, that times b1 plus da 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 plus bn over n. So I guess this is really saying that given that the numbers are arranged in that order, then a b bar is greater than or equal to a bar times b bar. This is quite a subtle inequality. There's quite a lot going on. So what I'm going to do is try and force our original equality into this form here. Okay, so what have we got? We've got a cubed over 1 plus b, 1 plus c, plus b cubed over 1 plus c, 1 plus a, plus c cubed over 1 plus a, 1 plus b. And now I need to write my a's and b's in decreasing order. So I'm going to presume that a is less than or equal to b, less than or equal to c. And then I've got 1 over 1 plus b, 1 plus c, less than or equal to 1 over 1 plus c, 1 plus a. I'm just reading the denominators from here. Less than or equal to 1 over 1 plus a, 1 plus b. Okay, so this is going to be my sequence A in Chebyshev's inequality, and this is going to be my sequence B. And what have I got? I've got A1, B1 plus A2, B2 plus A3, B3. I'll just write that again because my writing's getting a bit poor here. Just a minute. Plus A2, B2 plus A3, B3 over 3. Which way around is it? Greater than or equal to 1/3 A. Now I'm saying A1, B1, or let's just write it out. A1 plus A2 plus A3 times 1/3 B1 plus B2 plus B3. Okay, but I'm going to write A1, B1, C1, so A1 is A, A2 is B, A3 is C, B1 is 1 over 1 plus B, 1 plus C, B2 is going to be the next denominator, 1 over 1 plus C, 1 plus A, and the next one, B3, is going to be the final one, 1 over 1 plus A, 1 plus B. That's right, because each one misses out the letter that it refers to. Okay, so what can I do with that? So that tells me that, now what do I want on the left-hand side? No, I want to have cubes. I want to have cubes here. Still true, the inequality is still true, but my sequence A is going to have that. Cubed, c cubed. See how what I'm doing is what I'm trying to do is to force Chebyshev's inequality to work here, and I got most of it right. I got the 1 over the denominators right, and what I forgot was the cubes, but it doesn't matter. So now let's write out Chebyshev's inequality and hope that helps us. So that says this thing here, a1 b1 sigma ai bi over 3 equals a1 b1, which is a cubed over 1 plus b 1 plus c plus b cubed over 1 plus c 1 plus a plus c cubed over 1 plus a 1 plus b is greater than or equal to what? Well, well, let me pinch in a little bit here. That's greater than or equal to 1/3 of a1 plus a2 plus a3. So that's a cubed plus b cubed plus c cubed. I'll just neaten that up. Plus times 1/3 of, right, now it's going to start to get a little bit cleverer, isn't it? b1 plus b2 plus b3. So that is 1 over 1 plus b, 1 plus c. See, it misses out the a. Plus 1 over this misses out b, so it's going to be 1a, 1 plus c, plus 1 over, and this one misses out c, doesn't it? 1 over 1 plus a, 1 plus b. Close curly brackets, return. There we go. So this is the quantity that we're interested in, and Chebyshev's inequality has shown us that that quantity there is greater than or equal to, oh dear me, it's a bit of a mess, isn't it? Let's see if we can simplify that. That's going to be a cubed plus b cubed plus c cubed over 3 for the first bit, times, let's put everything over a common denominator, 1 plus a, 1 plus b, 1 plus c. The reason being that I want to get lots of products because I want to show, I want to use the arithmetic geometric mean inequality. So let's just try that, and that's going to be 1 plus b, no it's not, it's going to be 1 plus c, 1 plus a there for this one, 1 plus b plus 1 plus c, there we go. That's shaping up. A cubed plus b cubed plus c cubed over 3 times 3 plus a plus b plus c, 1 plus a, 1 plus b, 1 plus c. How do we deal with that? Well, I think we've made quite a lot of progress. We've turned a rather intractable thing with cubes and divisions and things into this rather pleasing formula here. What I'm going to do is I'm going to stop here, and I'm going to do the next one in a minute. So I'm just going to stop here, and we'll go on to the next one. This is a hard one.